Hi everyone. For activity 7, this one's a little bit longer and might take a little bit more time just because we are working with a set of data, actually 2 sets of data. One that has to do with more youth population, so people who are kind of in an adolescence / pre-adolescence phase, and then we'll also look at some data for older adults. And primarily what we're interested in observing are the changes in cardiorespiratory endurance over time. Now, both of the data sets that I've given you are based off of cross-sectional data. So you'll recall from some of our earlier lectures that cross-sectional data is when we take several groups of people that meet certain criteria. So typically in motor development, we are looking at various age groups. And then we take a specific measure for each of those age groups and compare them. And that's kind of how we infer developmental changes over time without actually having to take the time-consuming route of doing a longitudinal study design. So I've included some background information for you on what Lab Activity 10.1, which is based on youth endurance performance, what kind of the data in that entail. I've also given you a description of the data that came with Lab Activity 10.2 for older adults, so you can feel free to read through that. We won't be using HK Propel this week because I have modified all of the lab materials so that they're kind of in one place. So you shouldn't find any content related to Chapter 10 in HK Propel. Just go off of everything that is posted on Beachboard. For Lab Activity 10.1, you've been given some PACER scores for 5 boys and 5 girls that have been collected over 3 consecutive years. Now, based on the data that you've been provided, you're going to calculate the average score for the girls for each year as well as the average score for the boys. And then what we're going to do is graph out some relationships that we could observe across these data. So I'm going to go to the 10.1 PACER scores sheet in your Activity 7 data. You can see each of the individuals, their PACER scores, which are in the form of like the number of laps they were able to perform. And then I've included these little group average areas down at the bottom. Okay, so the way that you can calculate an average in Excel is by typing the equal symbol, put in the word average, and then you just highlight the cells that you want to average the values for. So in this case, it would be all of the lap values for each participant or each girl in year 1. And then we can see what the average number of laps was for our girls in year 1. From here, when you hover over this bottom little green square, you'll see that the cursor changes from a white plus sign to a black plus sign. If you click when the black plus sign shows up and drag across, your average function will then apply to the adjacent data. So we could do the same thing for our boys. So those are our calculations, and then you'll notice that this bottom table has auto-populated. I made it that way, so you shouldn't have to touch this bottom part at all. Now you're going to be making 3 graphs. One graph will be for the girls, where you're plotting individual scores as well as the group averages. One will be for boys, and then the other one will be looking at the girl and boy averages in comparison to one another. So basically the graph for the girls and the boys are an identical process, so I'll just do the graph for the girls, that way you can see how it works out. I've noticed that the data that originally came with the activity, we're from an older version of Excel, so sometimes it doesn't plot out the best. But what we're going to do is we're just going to highlight all of the girl data and like individual data as well as the group averages. You'll go to the Insert tab, and we're going to plot this as a bar graph. So these are going to be the bones of the chart. When you click on the chart, there should be a chart design tab that opens up in the top of your Excel app. So in that, you're going to add a primary horizontal and a primary vertical axis title. From here, the default font size in Excel is on the small side. I like mine a little bit bigger, that way it's a tad more legible. And you'll notice that we've got some missing bits of information, but this is kind of like the cleanest way that I've been able to get everything in a graph, so I'll help you fill this in. What we're looking at here is the girls' pacer performance, or girl pacer scores. I give you guys some titles that you can use. Actually, I think I have it, pacer scores for girls. So we can we'll just copy and paste from, we'll copy and paste from the instructions. That might be easier. Okay, so these are pacer scores for girls. On our x-axis, technically these are going to be each individual in the group averages. So as long as, like, instead of it being 1, 2, 3, 4, 5, 6, as long as that is labeled as girl 1 through 5 and the group average, we can actually get rid of that. And I'll show you how to fill in that information. The y-axis is going to be the outcome variable that was measured, which is the number of laps. Okay, and this is a simple quantity, so that means there's not going to be a unit of measurement. In order to change the series values as well as the x-axis values, we can either go to the Chart Design tab and select Data, or we can right-click on our graph and choose Select Data. This window will look different between if you have a Mac desktop version versus a Windows desktop version, but if you're in a Windows computer, you should be able to figure out what this is. So the series are representing the years, right? So we've got year 1, year 2, year 3, and they should be entered corresponding to series 1, 2, and 3. You can double check this. I'm going to cancel out of this really quick. You can double check this by cross-referencing. So girl 1, her year 1 value was 30, right? And then her next one was 38 and then 48. And the series values or colors kind of correspond with each one of those bars. So that's how you can double check that you're labeling your series correctly. But we can just put year 1 in the name for year 2 and then year 3 in the name boxes for each of these series. And then our horizontal axis labels are going to be girl 1 through 5 and then our group average. So this should automatically populate into your graph, where instead of 1, it's girl 1, instead of 2, it's girl 2, cross, and so on and so forth. Okay. Oh. Or not. Didn't take it. That's fine. Okay. Please. Thank you. Okay. So now we've got the appropriate labels. I don't really care where your legend is as long as it's appropriately labeled. If you wanted to change the position in your chart design tab, you just go to legend and then you can put it to the right if you wanted to. Okay. So you'll do the same graphing process for the boy averages and individual data. The other graph that you're going to be making is a line graph that compares your group averages. So I'm going to highlight the averages that are already in that little table, and we're going to insert a line graph with markers. So we should get something that kind of looks like that. I'll add in my axes labels, and actually same thing kind of goes for this graph. We don't really need an x-axis label because the labels will be the years 1 through 3. I'm going to change the font size so this is a little bit bigger for you guys on the screen. This graph is going to be labeled Pacer scores boys versus girls. Similar y-axis label being the number of laps. And I mean, if you wanted to, you could add that they're the average number of laps. That's technically more correct. And then again, to change our series values, double check which series is boys and which one is girls. So you could hover over any one of the points in these lines. If I hover over this blue point, I can see it's 28.6. So if I cross-reference that with my table, I can see that blue has been inserted as my girl group averages. So when I go into select data, series 1, which was blue, will be girls, and series 2, which is red, will be boys. My X or horizontal axis labels will be years 1 through 3. Oh, dang it, it did it again. That's so weird. Do what I say. Yeah, there we go. Okay. So this will be your averages for boys versus girls. Okay. Yeah, I think that's pretty much it for the graphs on these ones. From those graphs, I'm quickly going to jump down to the questions. You're going to note how average aerobic performance differed between genders, and then compare general trends as well as yearly trends. So general trends you're going to get from more of like the group averages. Yearly, you could also get it from looking individual to individual. But we'll also look at yearly trends and like from year 1 to 2, how did averages change or how did individual performance change? Okay, so you'll just note what you're observing in both the boys and the girls across years 1 through 3. And then you're also going to comment on if these trends are what you would have expected given the information that was presented in the lecture for this week. For question number 2, this is more of a hypothetical question. So let's say that boys and girls were tested at ages 12, 13, and 14. So these would be years 1, 2, and 3 respectively, which are considered average adolescent years for both boys and girls. Okay, a little bit on the earlier side for boys, a little bit on the later side for girls. But based on individual scores, so looking at each person in your data set for both girls and boys, are there any individuals that display unusual or delayed patterns of cardiorespiratory development? If so, list which individuals, so you can just comment like, oh, girl 1, right? Or boy 5, that type of thing. You'll list the individual and then kind of think about or list some reasons why you think their development may have progressed the way that it did. The last question that goes with this data set are just listing what the physiological changes are that would be expected as a result of aerobic training and exercise, specifically in children and adolescents. You're kind of just staying in that age group. Okay. For lab activity 10.2, I've given you guys a set of data that represent running and swimming events for Senior Olympics. I've noted which events are considered anaerobic and which ones are considered aerobic. So you'll be using that information to help put together your graphs. You're going to end up making 4 graphs total. One graph will be for women's anaerobic events. One will be for women's aerobic events. Another will be for men's anaerobic events. And then the fourth one will be for men's aerobic events. So we're going to be plotting all of the aerobic and all of the anaerobic events in the same chart. If you see that there is a blank cell, that means there was nobody in that age group that we collected data on. Okay, so these just represent group averages for different age groups based on the event that was performed. So up here in this top table we have the running events, and down in this bottom table we have the swimming events. Please take note of the units of measurement for each of these averages, because some of you might be looking at the numbers and then you're like, oh my god, like, how is there only a 7 unit difference between a 100-meter dash and a 5,000-meter run? It's because it's seconds versus minutes. Okay, so just make sure you keep note of that. All 4 graphs that we're making in this section are going to be line graphs. And I've kind of set up a template for you guys that I think is the easiest way to organize your data so that you can put it in a graph. You can note what category of events you're pulling out. There could be a column for the event, and then you'd have a column for each of your age groups. Underneath these, you would put the anaerobic events and then the corresponding values that go with those events. So if we're doing women's anaerobic events across age, the anaerobic events that were noted in the instructions were the 50-meter dash and the 100-meter dash for running. So I'm going to copy these, and then when I paste them, just make sure you're pasting values. I did do some calculations to adjust the original data, so I'm pretty sure that I've copied these correctly, but just in case, I would do paste values just to be safe. Okay. So those were the 2 anaerobic events for women in running events, and then the anaerobic swimming events were the 50-yard and the 100-yard freestyle. So we'll do the same thing where we'll paste values. And now we have a set of data. You'll notice that all of our variables are in seconds. And the easiest way I found to insert a graph for these is to highlight the values, go to Insert. We're doing a line graph with markers. If you wanted to highlight the event names and age groups, you can. I tried this out earlier and it didn't bode well for me, so this is why I'm doing it this way. But we'll add in a primary horizontal and vertical axis title. I'm going to change my legend to a right position just because that's a personal preference. The title for this will just be our women's anaerobic events across age. The y-axis is going to represent the race time or average race time in seconds. The x-axis will end up representing our age groups, and the values that we'll be plotting are in years. Whenever you have values that have a bunch of zeros at the end, so they could technically be rounded to a whole number, if you double click on the y-axis in the axis options like formatting toolbar, I like to change in the number tab, change it to a 0 number of decimal places so that it doesn't crowd your graph so much. If we right-click on the graph and choose Select Data, we can then name our series, so they'll be labeled accordingly. So Series 1 would be the 50-meter dash. Series 2 should be the 100-meter dash. 3, 50-yard freestyle. And 4 would be the 100-yard freestyle. The x-axis labels or the horizontal axis labels are going to be the age groups. So you have to select the age groups that are included in the data set. And then hopefully it keeps that. Ugh, I don't know why I'm having to do this twice. That's so weird. Okay, let's do this again. No! Oh wait, actually it did it. Okay, so this is what your graph would look like. I'm gonna increase my font size just so it's a little bit easier to read. Please make sure that you actually spread your graph size out. Some of you, if you keep it to the default size and it like smushes everything together, it becomes really difficult to read when you end up pasting it in your Word document. So just make sure that your age groups are separated enough by little spaces so that they don't run into each other. Make sure that your data correspond with the correct information. Okay, so if you wanted to, I didn't mention this in the previous examples, but if you like color and you wanted to change the color of your lines and markers, if you click on any one of these series, you see this color over here, you can change that if you want to. Okay. And there's an option to change both the line as well as the marker. Okay. I'm going to undo mine because I just keep it default. But that's how you would create the line graphs for this section. So you can feel free to make tables that are similar to this for the other 3 kind of groupings of data that you've been asked to graph. For the questions for lab activity 10.2, looking at your anaerobic performance graph, so between males and females, you're going to describe the trends in anaerobic performance. This can be either general across both genders or across males separate from females. If you notice gender differences, obviously you would want to comment on what those are. And then you're also going to identify at what ages notable declines in performance occur, and if there are differences in those ages or age groups between males and females. You'll do a similar process for the aerobic performance or the aerobic events. And then based on your questions or your answers to questions 4 and 5, what can you conclude about the relationship between aerobic and anaerobic performance and aging? So does aerobic performance or anaerobic performance, which one starts to decline first? Do they both start declining at the same time? We know there is a decline that's kind of inevitable with the aging process, but what can you conclude about how each of those types of performance changes with age as a factor? The last question you're answering is you're creating a list of at least 3 factors that could have influenced the graphical trends in older adulthood. So this could be in both aerobic and anaerobic performance, but just make sure you indicate if there's a specific factor that is impacting a certain type of performance more or less than another. Okay. I know the activity is probably going to be a little bit more time consuming than the lecture portion this module, so you do have the entirety of spring break as well as the entire week coming back from spring break to work on this. If you have any problems with Excel, please, please, please let me know. This isn't an Excel class. I've had some of you in my stats class, or I also currently have you in my stats class right now. So most of you know I'm pretty patient when it comes to helping out with graphs, but if you need to meet really quick over Zoom to figure out some issues, just please let me know or sign up for an office hours appointment in Calendly. Other than that, that's all I have for you for this module, so hopefully you get some good learning out of it, and I will see you guys after spring break. Have a great time.